Hi everybody! Today we are going to talk about how we study social behavior using rigorous scientific methods. Before starting this video, make sure that you've watched the other two external sources that I've posted for today. One of those is a crash course psychology video that offers a kind of head-spinningly whirlwind tour of research methods in psychology. And the other is a quick TEDx talk by a Dutch woman named Ionica Smeets. And she is talking in particular about the dangers of confusing correlational research with proof of causation. So again, both of those videos were very quick, very whirlwind tours of different kind of central concepts in psychological research methods. And I want to take the chance to potentially clear up some misconceptions that might be caused by those videos, because they don't cover everything in elaborate detail, and also expand a little bit on some of the operationalizations and methods that are particular to social psychology. Okay, so again, please watch the crash course psych video and the TED Talk videos before this one, because I will be kind of relying on those and building off of those too. Okay, so you probably remember, at the very least from the Ionica Smeets video, that a really crucial cross-cutting theme: correlation sometimes, but does not always, offer evidence of causation. And Ionica really relied on this example of the connection between ice cream and seemingly dangerous and undesirable consequences. In her case, she talked about a pretty strong correlation over time between week-to-week consumption of ice cream and week-to-week rates of drowning in the general population. You also see this example used where people talk about shark attacks. So powerful correlation between how many people are going to Baskin-Robbins or Cold Stone and how many people are having their limbs bitten off by gigantic sea creatures. And you probably have encountered these examples yourselves, right? So it is so evident in this case that there is nothing causally linking eating of ice cream to shark attacks, unless you think that the ice cream is sort of getting dribbled in the water and attracting all manner of sea predators, right? But we generally know that that's not actually the case. Instead, it's quite intuitive with this case to think about other potential causal connections. And the one that leaps to mind is the fact that people tend to eat more ice cream during certain times of year, in particular the hot months of summer. And those are also the times when people are going to the beach, hopping into the water, and either opening up the opportunity, unfortunately, for drowning or for being attacked by a shark. And so in this case, that's what we call a third variable problem. So Crash Course Psych does something that I think can be a little bit confusing, which is they illustrate this idea of correlation not equaling causation by using the example of an individual anecdote or case study. So for our purposes, let's imagine that you have a friend, Jake, and Jake thinks that every time he puts on his mask to go outside, he starts to feel drowsy, bleary-headed, he can't concentrate. So he's arguing that there is a causal connection here and that he should not have to wear his mask in public. So from the Crash Course Psych perspective, the problem with this is that Jake is just one person. Maybe Jake has a unique history with masks that wouldn't apply to other people. But here's the thing. This correlation does not equal causation problem doesn't totally go away just because you have lots of data points. You could also have a friend, Monica, who similarly feels drowsy and bleary-headed when she puts on a mask. You could have a friend, Bernice, who also feels kind of drowsy and kind of out of it when she puts on a mask. That would not solve the correlation equals causation problem. You could still potentially have these issues with third variables and alternate causes, right? So maybe what's really going on here is for each of these folks, they put on a mask when they're thinking about going outside to a crowded public place. And maybe this triggers a sense of fatigue with just all the news about the pandemic, concerns and worries about getting sick. And so maybe it's those concerns and worries about getting sick that are actually triggering the sense of fatigue or discomfort, rather than the mask wearing itself. Again, just having a lot of people who report the same problem doesn't mean you necessarily have strong evidence of causation. And I think Ionica Smeets does a really good job illustrating this with that short-sighted babies example, so I'm going to highlight it again just to reinforce it. She's talking about a study that was published where some researchers found that very little kids who slept in rooms with night lights tended to have higher incidence of short-sightedness later in life. So there's all this concern that breaks out, right? Are you damaging your kid's eyesight by having a nightlight in their nursery? And then it turns out the causal relationship is actually quite a bit more complicated than that. So this adorable little kid who's wearing his baby glasses is probably more likely to come from parents who themselves suffered from some kind of myopia. That's the scientific term for short-sightedness. It's those myopic parents who are more likely to bump into things in the night and who might have reason to have stronger illumination in the kid's nursery, right? So what was previously seemingly a causal relationship between the bright night lights and the cute little baby with his or her glasses is now understood to actually be the result of a third variable that directly causes both of these things. That's what we're worried about with correlation not equaling causation, not the fact that information might just come from one friend, one person offering anecdotal data, right? That's problematic, but for other reasons. Okay, so here's what I really want to dig into in a little bit more detail. And this is the distinction between observational and experimental methods. Your textbook goes into a great deal of detail about that. I am not going to repeat every kind of observational method. I am not going to rehash every layer that goes into an experiment. This is just going to be the high points. So observational methods are characterized by observing what's going on, walking into the natural world, or trying to assess just the lay of the land of what's actually going on in people's lives, watching, describing, and not doing something to actively change, intervene, or manipulate a situation. So watching and describing can take on different forms. This can include naturalistic observational methods. Classic one might be if you took a developmental psych course and your prof told you to go to a playground or go to a child care center, with permission of course, and simply have a notebook where you marked down how many times kids who appeared very, very little, 3-year-olds, 4-year-olds, did something physically violent to aggress against another kid versus how many times kids who were 6 or 7 did something that seemed physically or verbally aggressive, right? And so then you get data where you're just counting and you're describing in a pretty natural situation, do kids show an increase in aggressive verbal or physical behavior as they go from toddlerhood to middle childhood? That would be an observational study. Experiments are about asking if you actually change A, do you get some kind of follow-up outcome, follow-up change in B? If I do A, does B happen? If A, then B. And if not A, so also having the contrasting situation, does not B happen? You're intervening and manipulating, right? So you're not just measuring if A or if not A. You're not just measuring you've got 3-year-old kids versus 6-year-old kids. You're actually creating separate groups who experience separate situations, and then you're looking at what results from that. So here are some criteria for an experiment. You have an independent variable. Now I know that keeping independent and dependent variables, that vocabulary can be a little tricky to remember, but just try to remember the independent variable is the one that you are altering. So within the context of the experiment, it's what happens first. It's what comes first. And then the dependent variable is assumed to be causally dependent, causally affected by the independent variable. You have one thing that you change, that's the independent variable. And then you have one thing where you are observing and measuring what happens as a result of that original change. Another thing that's really important for an experiment is you have to have random assignment to condition. This is not random sampling. This does not mean you are, every student at Dickinson is equally likely to end up in your study. This does not mean every US adult is equally likely to end up in your study. This is about once you have a population of people you've recruited for the study, making sure that each of them is equally likely to end up in each of your experimental groups. I know that's a little bit abstract. Let me give a more concrete example. You could set up an experimental situation where some people were getting a heavy dose of caffeine and then doing cognitive tests, just like was talked about in the crash course video, and some people were getting no caffeine, decaf, placebo. What might happen if you decided that for convenience sake, you wanted to brew up all your coffee at the same time? So your entire batch of caffeinated coffee, that's what you're going to do in the morning. Your entire batch of decaf coffee, that's what you're going to do in the afternoon, just so you can make like one really mega batch of it, right? So you get all your people that you recruit in the morning and you're testing them at 7 a.m., 8 a.m., 9 a.m. and they're getting the heavy dose of caffeine. And you find that they do really well on your cognitive test. Then you have the batch of decaf that you brew. You're testing people at 2 p.m., 3 p.m., 4 p.m. And you find that they're a lot slower to complete the test or complete the maze. Could be due to your caffeine, but it could be due to a lot of other things. Maybe people tend to actually be more alert in the morning. And so you're capturing in reality the effect of testing people at 9 a.m. versus 2 p.m. Maybe you're getting a different kind of person who's agreeing to take the study at 9 a.m. Maybe those are people who have really early morning language classes or really early morning OChem classes. And they actually are a little bit more academically savvy. And for all those reasons, if you've got groups of people who could be asymmetric or unequal across your different experimental groups, you've really blown your chances of understanding what is actually causing any ultimate difference in your follow-up, in your dependent variable. So again, random assignment means everyone has an equal chance of ending up in any of your experimental conditions. Experiments don't always have to happen in the lab, however. It's important to keep in mind. So, just to recap, observational methods are not bad, right? They don't offer strong evidence of causality, but they help us to understand patterns that exist in the world as it actually is. If you run a big survey, and for instance, you find that people who have lower incomes in the United States report being less satisfied with their lives, that's not an experimental study, but that data is still immensely important for understanding a societally crucial dynamic, right? That's a huge clue that maybe there's something going on where we're not supporting low SES folks in our country, for instance. Experimental methods, however, are less about describing the world as it is and trying to look under the hood, understand the causal relationships between variables, and also by understanding the causal relationships between variables, this gives you the power to then potentially change that relationship, change Y by manipulating X. So if you learn, for instance, that increased caffeine actually does improve cognitive performance rather than just being correlated with cognitive performance, that gives you a good clue that you actually might want to start drinking more coffee before your classes. Okay, so to totally cap things off, I want to run you through a quick example of how correlational and experimental methods can be paired together in a single set of studies to give different pictures on the same phenomenon. How correlational and experimental methods can actually be used harmoniously, right, to maybe feel even more confident that you're documenting a real and important phenomenon. And for this, I'm going to talk about some actual research that was conducted by Eli Finkel and his colleagues in 2009. And they were really interested in this question of whether self-control, so your ability to regulate your own behavior, control impulses, control your emotions, is related to somebody's likelihood of perpetrating intimate partner violence. So that would be emotionally or physically hurting someone that you're in a romantic relationship with. In other words, do people who have a really good handle on themselves, is that actually a tool that makes it easier for people to avoid doing something potentially harmful or damaging to a romantic partner? And in their first set of studies, they used correlational survey methods. And once again, this is going to allow them to get a picture of the world as it actually is. So the way that they did this is they took a sample. It was actually over 900 young adults living in rural areas in North Carolina. So a really big, broad sample. They first gave them a validated scale of dispositional, meaning kind of personality level self-control. This means asking people things like, do you often act on the spur of the moment without stopping to think? People can indicate they strongly agree with that, sort of agree with that, don't agree with that. I often do whatever brings me pleasure in the here and now, even at the cost of some distant goal. And then they asked people about actual enacted physically violent behavior towards somebody that they were in a relationship with or had had sex with or been on a date with in the last 12 months. So they were actually asking people in the past year of anyone you were romantically linked to. Did you slap one of those people? Did you hit one of those people? And so on and so forth. It was 16 total behaviors. Thankfully, the percentage of people who said that they did any of these was the minority of the sample. And this is what they found. So people who fell towards the very low end of that self-control scale, these are people doing lots of impulsive things, saying they can't kind of delay gratification. They actually, on average, had engaged in a total of 8 violent acts. This could mean, multiple times you might have slapped a romantic partner. And the people who said, yeah, I do a really good job of controlling my impulses, typically reported no or almost no violent acts. So this is really intriguing, but again, it's correlational. There might be alternate variables that actually explain this relationship. Maybe what's really going on here is the people who are in high stress or difficult circumstances, maybe experiencing economic stress, for instance, are both people who are having their self-control drained. They're reporting that it's difficult to experience self-control, and totally separately, those difficult circumstances are leading to the kinds of negative emotions and conflict that might trigger violent behavior. Maybe there is no direct connection between self-control and intimate partner violence. And for that, that's why you need experimental methods. So, did Finkel et al. Actually try to set up a situation where people were physically violent towards their partner in the lab? Absolutely not. That would be wildly unethical. So they did something that got like a quarter of the way there. And here's what they did. They experimentally manipulated someone's degree of momentary self-control. They did this by cognitively overloading half of their participants. This is actually in prior studies been shown. If you provide someone with way too much information to navigate, in this case, people had to watch a video where they had a bunch of words and other kind of visual stimuli that kept flashing on the screen. They're supposed to be memorizing what's happening, but they're also, getting wildly distracted. It's very frustrating, it's very overloading. Half of people did that, half of people did something calming and easy. Then, cross-cutting that, half of people received negative, insulting feedback from their romantic partner. This meant that they had actually done a kind of creative finger painting task. They thought that this finger painting was being delivered to the romantic partner in another room, and then they get a note back from the partner saying, your finger painting kind of sucked. Or they got positive feedback where the person said, this is wonderful, I love it. So half of people getting negative feedback, half of people getting positive feedback. This is the dependent variable. Everybody got the chance to determine what their partner did for a follow-up task. And in all cases, the partner was supposed to do yoga. But you, as the participant, actually got to choose what kind of yoga they did and for how long. And you see a whole list of different yoga positions. Some of them are described as being very easy and comfortable, and some of them are described as being very difficult and, in fact, extremely uncomfortable. So they looked at the minutes of those really difficult positions, the ones where your muscles would start cramping after a couple seconds. How many minutes of that difficult yoga do you assign? And there was their stand-in for how much somebody might lash out and retaliate against the partner. And here's what they found. So, for people who had no cognitive overload, they had originally done an easy task that left them feeling breezy and calm. For them, it didn't matter whether they got the insulting feedback from the partner or the really glowing feedback. In both cases, they're not assigning much painful yoga, about 30 seconds. For the people who had gotten all this information that was kind of being volleyed at them, where prior research has shown that actually affects your ability to regulate yourself, affects your impulse control. If those people got negative feedback from their partner, if they felt insulted, if they might have had a reason to lash out, in that case, they assign about 45 seconds, so 50% more of those excruciatingly difficult yoga poses. So we have the correlational side, which shows us what happens in the real world, seems to indicate a link between self-control and intimate partner violence. We've got the experimental stuff. So even with people randomly assigned a condition, if you overload them, they seem to show more impulsive kind of retaliatory behavior. You put those two together, and you have a pretty strong set of evidence that there's a real link between these two variables. All right, so that's it for this video. Thanks for watching.